G'day, welcome to the Tech Math channel. What we're going to be having a look at in this video is how to work out probability over multiple events. An example of this, so say you maybe had a coin and you flipped it and you wanted to know how many different times you would get heads. So you're going to flip it twice. Could you get heads twice? Okay, so heads and then heads again. What would be the probability of that? Or for example, what we'd be having a look at is we had a bag of marbles like we have here. It had, 3 blue marbles and 3 red marbles, and what would be the probability if we were to draw out 2 marbles and maybe getting both of them being red? And so we're going to be looking at these types of questions. Okay, what you're going to notice with these is these probabilities occur over multiple events and are easy to work out. We're just going to keep in mind a few things. In this video, we're going to be looking at some of these sort of things. So we're going to be looking at product and addition rules in probability, as well as events, how they can be independent or dependent on each other, and how these affect our calculations. So let's just get on and have a look at these with a few examples. And don't forget, if you like this video, don't just sit there and lightly caress the like button. Actually smash that like button, smash it. Hey, and if you haven't subscribed already, please subscribe. Anyway, I'm just going to look at a few examples. Okay, for the first example, we're going to have a look at this. We're going to be considering flipping a coin twice and just having a bit of a look about how we might work out various probabilities of outcomes that might occur. So to illustrate this, a really good way would be a tree diagram. So we have our first flip and we could get 2 possible outcomes. We could get a head or a tail. So we get a head or a tail. This would be our first flip. We have a second flip where we have also 2 possible outcomes. We get, once again, a head or a tail, or we could have got a tails first and we could get a head or a tail. Now just a couple of things which is really important to probably get at this stage, which is this. What you're going to notice is the probability of each event occurring. A probability of getting a head is 1 in 2. The probability of getting a tail is 1 in 2. And so our first flip here, the probability of getting a head is 1 in 2. The probability of getting a tail is 1 in 2. If we consider our second flip, you'll probably notice really quickly that it's also the probability of getting a head here is a 1 in 2, and the probability of getting a tail here is 1 in 2. That is to say that these particular events in the second flip are independent of the first. I'm actually going to write that down. It's a really important thing to get. This word here, that this is independent. Okay, that each particular outcome or each probability is independent, or each event is independent of the other event. Okay, it's not affected by it. So we have a half chance of this occurring and a half chance of this occurring. Okay, so you can see this so far. We've set this up and it's all pretty nice. So what is the probability of this happening? What is the probability of getting a head then a head? We can use our probabilities here to work this out, okay, because the probability of getting a head at the start is equal to a half, and the probability of getting, so this particular thing here, we could get a head here, and we could get a head here, and the probability of getting the second one is also a half. Now this gets to a first rule of probability with multiple events, and that's the product rule. Pretty much the probability of 2 or more events occurring together can be calculated. So 2 or more events, getting a head and getting a head, can be calculated simply by multiplying these individual probabilities. Okay, so the probability, 1 times 1 is 1, 2 times 2 is 4. The probability of getting 2 heads is 1 in 4. Okay, what about the probability of getting tails? Tails and tails. You'll probably look at this and go, okay, it's the same sort of thing. The probability of getting a tails is a half. The probability of getting a tails is also a half. And so we're talking about this event followed by this event. We're going to multiply these. This is a 1 in 4 chance. Okay, I'm just going to take this one step further and show you a different rule in this. Just give myself a bit of space here. So I'm going to get rid of these 2 probabilities here. And we're going to talk about a different thing that might occur. What about the probability of getting 1 head and 1 tail, but not necessarily in that order? It might be a tail and a head, or a head and a tail. And you're going to see to do that, we actually have 2 different ways that can occur. We could first off get a head and then a tail, or we could get a tail and then a head. So I'm going to write both of these ones down. So first off, if we go head tail, The probability of getting that is a half of getting that first head, and then a half. You might say, okay, we're going to multiply those because they're that particular, this event followed by this event. We're going to multiply these. This is a 1 in 4 chance of getting a head then a tail. The chance of getting a tail then a head is also a half times a half. Okay, a half times a half, which is equal to a quarter. So this gets to our second rule when we're looking at multiple events and probability, is this. If we're talking about two events that are mutually exclusive, that are not affecting one another, we're trying to find out the total probability, say, of something like with a tail and a head here, and there's a couple of different ways this can occur for our outcomes. What we do is we're going to add these. We're going to add our quarter and our quarter to get the total probability, because a head and a tail is the same as a tail and a head. So what's a quarter plus a quarter? You'd probably look at it and say, okay, that's 2 quarters. Okay, so the probability of that occurring is 2 quarters, okay, or a half. So something to be aware of, okay? So that's the product rule, where we multiply these if we're looking at something occurring in a line like that. And if we've got something which is occurring, and we're saying it's we want this and this occurring, we're going to add them together, okay? That's the addition rule. So I'm going to go through another example and show you just a variation of this. All right, in this example, what we're going to have a look at is we have a bag, and it has 3 blue marbles and 2 red marbles. And we're going to take 2 marbles out. Now, we're going to work out also now what our different probabilities or different outcomes could be and the probabilities of those outcomes occurring. So, once again, let's draw up a tree diagram. So, we have our first event where we're taking out the first marble. Okay, so the first marble, you'll probably look at and say, okay, we could either end up with a blue marble or we could end up with a red marble. So, we do that, then we're going to pull out the blue marble. We get rid of that, for instance, and then the next event, what we could do is we might end up with a blue marble or a red marble. Or if we maybe get a red one first, we could end up with a blue marble or a red marble. Okay, so let's have a bit of a look here about the various probabilities of each individual part here. Now, this is something to be very, very wary of, because the probability of each event is not independent. Okay, each particular event is not independent of the other. I'll show you what I mean by that. So say, for instance, I pull this first blue marble out. You can probably guess, okay, there's 3 blue marbles out of a total of 5 marbles. For the reds, there is 2 out of 5. I have a 2 in 5 chance of getting a red marble first. And that's for our first removal. For the second one, what you might notice is this. If I was to remove, okay, we pick a blue marble and we get rid of it. Now what's the actual probability of getting a blue marble? Now, because these are not independent, they are dependent on one another. This actually now depends, the probability of this depends on what happened here. We have 2 blue marbles now out of a possible 4. And to get a red, we have 2 out of 4. Okay, maybe that didn't happen. And maybe what happened instead is we went down here and we picked a red out first. So we got rid of a red. What's the probability of getting a blue marble? There's 3 out of 4. The probability of getting a red is 1 out of 4. And this is an example of a dependent. I'll write that down. These are where we have different events that are dependent on each other. Dependent, okay? And it's something to be really, really aware of, because it changes these probabilities as we go. A bit of a hint here. What you might see is occasionally you'll see this described as 2 marbles are taken out without replacement. If they say they are replaced, what we're talking about is the marbles get put back in, and what it would mean is that we would end up with an independent type scenario, okay, where we'd end up with still 5 marbles in here, so it wouldn't really affect these later ones, and it wouldn't affect the probabilities here. So you'll probably notice here that we can work out probabilities here. What's the probability of getting 2 blues? Or I'm going to go through each one of these. What's the probability of getting a blue and a red? What's the probability of getting a red and a blue? Red and a blue. What's the probability of getting a red and a red? Okay, let's have a quick look at these. And these are all going to end up being product ones. We're going to multiply these as we go along. The product, we've got a 3 in 5 chance of getting the first blue. We have a 2 in 4 chance of getting the second blue. Multiply these here. 2 times 3 is equal to 6. 5 times 4 is equal to 20. Now, I know you could simplify this further. I'm going to leave that to you. I'm not going to do that right now because, let's face it, I'm going to run out of space if I do that. What about the probability of getting a blue, then a red? There's a 3 in 5 chance of getting the blue. And to get this red here, there's a 2 in 4 chance. So this also is a 6 in 20 probability. This one here, we have a 2 in 5 chance of getting a red first, and then a blue. We have a 3 in 4 chance. We're going to multiply those. We end up with once again, a 6 out of 20 probability. To get 2 reds, there's a 2 in 5 chance at the start of actually getting the first red, and then there's a 1 in 4 chance of getting that one, a second red. So 2 times 1 is 2, over 20. You're going to notice that 2 plus 6 plus 6 plus 6 adds up to 20. So all our probabilities are there, and that's the product rule in action there. Now I might also say, okay, we can actually do this a little bit differently, and maybe I say, okay, what about a blue and a red, but not in any particular order? And you go, okay, well, we'd have to add the 6 out of 20. Okay, I'll even write this down here. I'm going to be struggling for space anyway. I'm going to rub this out. I reckon I'll put it here. What's the probability of the 1 red and 1 blue? You can sit there and go, okay, well, we've got 2 ways this could happen. We could get a blue and a red, which is a 6 out of 20. And we've got a red and a blue, which is a 6 out of 20. And we're going to add these, okay? This is a 12 out of 20 probability of occurring. Okay. So this is an example of a dependent event, okay, where an event actually changes the probabilities of each little part here, and something to be wary of. What about one more example? Okay, I'm going to not vary this one up too much because I think it maybe is a good idea to do this at this stage. We're going to go 2 marbles taken out, same sort of bag. We have 2 reds and 3 blues, but this time with replacement. Let's see what happens. Okay, so if we take out the blue marble first, you have a 3 in 5 chance. To get a red marble in the first drawing, you have a 2 in 5 chance. Now, imagine we take this blue marble out. Here we go. We're going to take it out, but it's going to get replaced. Okay, so that means we're putting it back in. So I've taken it out, but now I'm putting it straight back in. So what's the chance now of getting a blue marble? And you go, okay, well, it's still actually 3 out of 5. And to get a red is 2 out of 5. Okay, you're going to notice that the actual probabilities are not changing here. And we almost treat this event, well, we exactly treat this event as independent because these outcomes here are not affected. These events here are not affected by this previous event. This would be a 3 out of 5, and this would be a 2 out of 5. And so hence our overall probabilities would change. You remember this, our probability of getting now, say, a blue and a blue is, we're going to multiply these through. It's going to be 3 out of 5 times 3 out of 5, which is going to be 3 times 3 is 9 over 25. We've got a probability of getting, say, a blue and a red. A blue and a red is going to be equal to 3 out of 5 times 2 out of 5, which is going to be 6 out of 25. Okay, notice the probabilities are all of a sudden different. The probabilities of getting a red and a blue is equal to 2 out of 5 times 3 out of 5. 2 out of 5 times 3 out of 5, which is going to be equal to 6 out of 25. The probability of getting a red and a red is equal to 2 out of 5 times 2 out of 5, which is going to be 4 out of 25. So be really, really careful of these when you do these. That if it's replacement, that you are going to treat it differently to if it's not replaced, okay? So, you can actually now say, okay, what's the probability? You can already say what the probability of 2 blues or 2 reds is. Maybe the probability of at least 1 blue. And what's the probability of this? Well, this one has at least 1 blue, this one has at least 1 blue, this one has at least 1 blue. It's out of 25 because we're going to add all these together. So 25, 25, 25, the denominator's staying the same. 9 plus 6 is 12. We have 21. It's 21 out of 25 probability. Tell you what, we'll do one more. Okay, in this example, what we're going to have a look at is a scenario we have 6 apples with 3 of them are good and 3 of them are bad. And we're going to take 2 out at random. Okay, so let's draw up our tree. Here we have good, bad. That's our first one. We have good, bad, good, bad. I reckon you should give this a go without waiting for me, by the way. We're going to take these out at random. And remember, we're not actually putting them back. There is no replacement. So what I recommend you go through first, can you work out the probabilities of each of these particular outcomes of getting a probability of getting a good, the probability of getting a good bad, the probability of getting a bad good, and the probability of getting a bad bad. And I'll just leave that one. We'll see how we go with those ones. Go for it. So first off, go through and work out your probabilities of each particular event, and then go from there using those product rules. Okay, so give it a fly. Hopefully you did all right. Okay, the probability of getting a good apple to start off with is 3 out of 6, or a half. It's 3 out of 6 here. As well, if you choose a good apple first, I'm just going to say we choose one of these. We'll get rid of it. So what's our probability now of getting a good apple? You might say, okay, it's 2 out of 5. The probability of getting a bad apple is 3 out of 5, because these are actually particular dependent events here. Okay, well maybe that didn't happen. Maybe my apple was okay, and there it is. And instead what we did is we took a bad apple out first. Okay, let's have a look at what happens here. You know, the probability of getting a good apple is now going to be 3 out of 5. We have 3 good apples out of 5 apples. The probability of getting a bad apple is going to be 2 out of 5. Okay, what's our different probabilities here? Probability of getting 2 good apples is 3 out of 6 times 2 out of 5. We're just following up that pathway there. 3 2s are 6. 6 5s are 30. What's the probability of getting a good and a bad? You might go, okay, that's a 3 out of 6 times 3 out of 5, which is going to be 3 3s and 9 out of 30. The probability of getting a bad than a good, we have 3 out of 6 times 3 out of 5. 3 out of 6 times 3 out of 5, which is going to be 9 out of 30 also. And the probability of getting 2 bads is 3 out of 6 times 2 out of 5. 3 out of 6 times 2 out of 5, which is going to be 6 out of 30. There you go. How'd you go with that? Now, if I was to say once again, what's the probability of getting a good apple and a bad apple? You'd probably go, okay, well, and I might say now, what's the probability of getting a good apple and a bad apple? And you might say, okay, in any order, we could add these two together. 9 out of 30 plus 9 out of 30 would give us, of at least getting a good apple and getting a bad apple, would give us an 18 out of 30 probability. Anyway, look, hopefully you found this of some use. That's the product addition rules, multiple probability events there. Hopefully this video was of some help to you. If it was, please like it, please subscribe. Hey, look, I'm going to put a dodgy call out there. There is merch, there is Patreon. Please support the Tech Math channel. All the more I can get supported there, the more free math I can get out there. Look, I'm going to keep making it anyway, but your support would be lovely. Anyway, you're also going to see I've been putting up feeds asking what videos do you guys want made, and you might have a particular preference. And if you do, put them up there, and I'll look at making them in the future. Anyway, thanks for watching. See you next time.